Today, two different eras of computing hardware are colliding. The flawless, cycle-accurate FPGA power of the Commodore 64 Ultimate and the glorious mechanical output of the 1985 Okidata 120 dot matrix printer. There was something undeniably physical and satisfying about printing in the 80s. You didn't just click print and walk away, it was an event. It was the high-pitched whine of a 9-pin printer head hitting the ribbon, the anticipation of watching a picture being born line by line. It was the distinct smell of fresh ribbon ink and the incredibly satisfying ritual of tearing off the perforated edges and folding those tractor-fed strips into little accordion snakes. If we look back at vintage computer magazines like Compute and Run from 1985 and 1986, the Okidata 120 was heavily advertised under the slogan Rational, Functional, Precise, with a suggested retail price of $269. It promised a blazing 120 characters per second in draft mode, 30 characters per second in near letter quality, and a self-inking Clean Hands ribbon cartridge. But these printers were more than just hardware. They were the centerpiece of 1980s culture. Armed with continuous fan-fold paper, people transformed their homes, offices, and classrooms into personal print shops. Banners declaring happy birthday or welcome home became a symbol of your family's tech status, proving you had the knowledge and a computer to automate your creativity. This specific Okidata 120 was a donation to a thrift store. Let's see what's inside. We've got the original box with the handle. It looks like it's in decent shape. There's a little bit of damage here. It looks like something wet was placed on the box at some point. Okidata 120 personal printer for Commodore computers. New now features near letter quality printing. We've got the handle still here. It looks like it was purchased at Service Merchandise, which was a classic place back then to get jewelry, home goods, and apparently Okidata printers. Got a side panel with more information. Bold statement, the Okidata 120 personal printer for Commodore computers, data/word processing and dramatic graphics in one versatile package. Okidata 120 delivers crisp bidirectional data processing printing at a speedy 120 characters per second. That's quicker than any Commodore printer and significantly faster than an advanced electronic typewriter. We remember electronic typewriters, don't we? It also mentions the self-inking Clean Hands ribbon cartridge that delivers long-lasting performance and provides legibility up to 3 million characters. A little blurb about the space. Position your Okidata 120 anywhere, just 3 inches high and 9 pounds light. It's stingy on space and it's quiet too. Well, I don't know about quiet compared to modern printers, but I guess back in the mid-80s, it was considered quiet. Let's open it up and see what's inside. The covers come off. We'll reattach that. That water that has come before this was sold, looks like it's soaked through this little information card. And it's just a warning to remove the shipping retainer before using the printer. I'm sure it's already been removed. I don't think this is new old stock. In fact, you can see some plastic that was originally on, this is probably the printer cartridge. It looks like the shape of that. I don't know what was in these bags. Cables, perhaps. We have some ancient silica gel that I'm sure has done its duty and has soaked up over 40 years of humidity. Fancy do not eat still applies back then. We have a product guide issued from 1986. Also with that liquid. Couple of extra things mentioning near letter quality mode, stuff on the control panel, etc. We have our power cord. So looks like this knob has come off and it does seem to be cracked. We'll see if that makes a difference. An IEC cable, along with the infamous plasticizer reaction with the styrofoam. So I'll get that cleaned off. I have plenty of IEC cables. I don't necessarily have to use this one. Our manual, still in good shape. It did not get hit by whatever that liquid was. Looks like this is some plastic packing material. Some fuses. And it looks like some test printouts from the previous owner. Looks like they started with just a test pattern, or maybe this actually came from the printer because I'm guessing that's a firmware version. And then a couple other prints. The Okidata 120 prints like this. This prints 2. Normal printing, double width. And now some text. Word writer, word processing system. It looks like this is just like a demo paragraph from the TimeWorks Data Manager or Data Manager 2 using the report writer option from that program. I think we know what the person that had this printer before used to create their documents. And then some very ancient tractor fed paper. One side of the tractor feed missing. That's okay. I'm going to move this over to the workbench and we'll get it cleaned up and ready to go. The outside of the printer is remarkably clean. I see just a little bit of dirt, but nothing egregious. The acrylic portion, the transparent portion, isn't scratched. It's pretty much new. So instead of using my usual cleaner, I'm just going to use a bit of distilled water and a microfiber cloth just to get the surface dust out. And we'll take it from there. Regarding the missing knob, as you can see, the interior has a pin that's sticking down that matches the slot on this knob, and it looks like it's going to be okay. The part that was cracked off is at the very end. Once fully inserted, that pin should be all the way down there, so I don't think that's going to be a problem. I'm just going to reattach it. I think that what had happened was when it was donated, the knob was still in there, and it got shifted around. And the broken piece of plastic is not inside. I shook the printer. There's nothing loose inside, so I'm not sure what happened to it. But I should be able to just push this down. There we go. And it's not going anywhere. That crack really doesn't affect the operation of the printer. As suspected, everything on here was basically surface dust. There's one small marking right there that is not coming out with water. I don't know if it's paint or perhaps some of that styrofoam that has reacted with the plastic and has set in. I just have a Mr. Clean Magic eraser. Once again, this is slightly abrasive. Only use it on spots that are matte. Never use it on transparent surfaces. The marking has mostly come off. There's still a little bit there, but I can live with that. The paper feed also just has a little bit of dust. It's not bad. Let's get the cover off and take a look at the inside. Wow, it looks immaculate. I thought there would be paper dust and carbon all over the place, maybe pieces of ribbon. Totally shiny. There's a couple spots here and there. You can tell up here there's a few pieces of paper dust. The roller looks good. There's a couple spots there where paper's adhered. The original ribbon is here. I'm going to change it. I'm sure it's dried out. The first thing I'm going to do is see if there's anything on this roller. I've got peck pads. These are lint-free. They're not going to leave some residue behind. And to clean the roller, I've got the American Recorder S721H cleaning fluid. It's used for VCRs. It's safe for rubber. So I'm not worried about it degrading that. Let's see if any ink comes off of here. No, it's clean. It does say made in Japan. This has to be the original cartridge. The ones that I have, I'm sure, were made in China. But even looking under the printhead and around the printhead, it's clean. I just see a couple of fingerprints down here. I don't know if that was from the factory or the user. Now that the roller's been cleaned, which is important because you want to make sure that it doesn't slip feeding paper through, and ink residue and other things that are stuck on there will contribute to that, I'm going to look at this rail that the printhead slides along. There probably was some sort of lubricant originally on there to help glide it along. It's long since dried up. What I'm going to do is use some isopropyl alcohol, and I'm just going to clean off any of the remaining residue that's on there. I'm going to add some lubrication to that rail that the printhead moves across on, just like our drive rails. Needs a little bit of lubrication. Now, what I'm using is sewing machine oil. It's great because it's a highly refined, low viscosity, non-detergent mineral oil designed specifically for fast-moving precision machinery. It won't oxidize, dry out, or get gummy over years of inactivity. Printhead cartridges slide along that polished steel rail on bronze or brass bushings. That sewing machine oil will soak into the microscopic pores of those bushings without creating drag by viscosity on the stepper motor. I've got a PEC pad. I'm just going to put a drop or two on here. Just need a very small amount. I'm not going to apply it directly to the rod because I don't want it to gunk up as far as dropping off. And then I'm just going to go across and just put in a very thin film of this oil on the rod. Next, I'm just going to slide the printhead back and forth. One comment, never use WD-40 on this rail. It's a solvent and disperses water, not a long-term lubricant. It'll evaporate quickly and it'll leave behind a tacky film that will attract dirt and dust. Another thing that you might be tempted to use is that 3-in-1 multi-purpose oil. Avoid that. It contains vegetable-based additives that'll gum up over time. Final thing that you might be tempted to use is the white lithium or silicone grease that we use on drive rails. And although it's okay on that, on a printer, it will cause too much resistance for that print head to move back and forth. Got a brand new print cartridge. It's pretty much exactly physically to the old one, except the knob is black instead of blue. And this is made in China versus Japan for the original. There is a plastic guard there, goes on the far end of the printhead. Putting the cover back on, we have 3 slots and 3 guides. Our paper guide just fits into those 2 slots there. We're all set to hook it up to the Ultimate. While I was setting up the printer, I noticed something. The protective plastic on the front label is still on the printer. You might have seen my other videos where I found this as well. So I am going to peel it off. We should proudly see the printer in its original state as it was meant to be. There we go. Perfect. I'm going to hook the rest of it up and we're going to test it out. I'm ready to load the paper. I've got it in back of the printer. All right, looks like we're good to go. I'm gonna leave this cover off so you can see it printing. Just gonna bring it up to the perforation. There we go. Turning it on. All good, no errors. Let's check the form feed. Okay, that's good. We've got one page fully fed, line feed. Yep, it popped it up. I'm just going to scroll it down a little bit. And I'm going to set the top of form. Should be ready to go. To test out the printer, I'm just going to use basic, quick command. Almost ate itself because I didn't have the cover on, but it did work. Here we go. We have Hello World printed on the piece of paper that was fed into the printer. The ribbon looks fine, no problems there. So it looks like it worked. What makes the Okidata 120 so special? While most printers back then required a third-party parallel interface, like this Z-Tech Super Graphics Junior to work with a C64, the Okidata 120 featured a built-in Commodore serial IEC port. The 120 was basically a commercial-grade Okidata Microline 180 chassis adapted for the home market. It featured a rugged 9-pin printhead, an 80-column carriage, and native support for the Commodore Petsky character set. Connecting it to the C64 Ultimate was as simple as plugging in the IEC cable right into the back of the 1541 disk drive that I have. If you're using a virtual drive, of course, you just plug it into the back of the Ultimate directly. Because the Commodore IEC bus is a shared serial network, we just set our software to address device 4 or 5 for the printer. Here's something to keep in mind that you may have forgotten. Never store floppy disks on top of the printer. The electromagnet inside this 9-pin impact head creates a localized magnetic field strong enough to corrupt data on a 5¼ inch floppy resting directly above it. Of course, we can't talk about printing in the 80s without mentioning this. The software that started a revolution, Broderbund's The Print Shop. The program was originally conceived by David Balsam and Martin Kahn as a digital greeting card program called Perfect Occasion. The idea was that people would create a disk containing their greeting card and then send it off to a recipient to view on their own computer. Broderbund's co-founder, Doug Carlston, convinced them to redesign it to generate an actual printout. The Commodore 64 port was programmed by a teenager named Corey Kosak, who made enough in royalties to buy a Porsche before he even went to college. The print shop was a huge success. By 1987, sales of this single program accounted for 4% of the entire United States consumer software market. Let's take a look and see what's inside the print shop. It's got the box that was inside a sleeve. I got this from a thrift store from Ohio, and I'm not going to dox the owner, but I know that a gentleman named Jason owned this. So Jason from Marion, Ohio, we're going to go through your copy of the print shop. We've got a Broderbund Synapse software catalog. And it looks like Jason has printed out on a color printer a little thing that says, "Don't bend fragile." Got some gold colored envelopes. The print shop reference card with an example of the different fonts, commands, graphics. Something from Brightline Pixelite Computer Products from Richmond, California. Color for your computer. Print t-shirts with your computer. So it looks like they manufacture different color index cards, labels, etc. Jason did try to print stuff out. Looks like we have a little calendar graphic of the month of June, a couple guys smiling below. We've got our warranty card. More ads for the print shop. We've got a paper pack ad, print shop companion, a graphics library. And we have some gold pin feed paper. I can tell this was included in the package and not an aftermarket because the border says Broderbund software. And it looks like Jason had an Okidata printer. It was an Okamate 20, which was a different type of printer than this one. I believe this is the one that had like a ink pack that was waxy and not a typical ribbon. You've got that pin feed gold paper and then the manual for the Commodore 64. One other thing, it looks like there's a price inside the box, which is real weird. How would you know the price if the box was closed? But apparently it was $44.95, discounted to $40.46 with 15% off. I have our print shop disc in the 1541. It is actually side 2, which is intended for Commodore printers, even though this is an Okidata machine. That's because it's using a direct IEC cable. The printers on side 1 are for those that are connected through a Centronics parallel interface. Let's get this loaded. No Jiffy DOS, it's going to take a little while. And here we go, we're at the main menu. So of course, the flagship things people printed were banners. I'm going to do that. You're actually going to see how long it took, all of the noise that it was going to make. We'll go with a tech font. Sure, solid. And we'll look for a graphic. I'll go with a floppy disk, both before and after. We're only going to need one copy. It will be too long for that. So I have a direct printer view to show you exactly what it looks like. Here we go. There we go. Back in the 80s, you might have been tempted to walk away, but what if there was a problem in between? Your paper went off the socket, or perhaps the paper looped around and went back. You really couldn't stray too far. You had to keep an eye on things. So this is something that's really spectacular because you can't do this nowadays. You'd have to print a bunch of pages on an inkjet or laserjet printer and tape them all together. This banner is quintessentially 80s. Here we go. Our beautiful banner. It would be happy birthday, welcome home, happy retirement, etc. The essential 80s decor. One other thing I'm going to show you is the self-test and firmware display. So I'm going to turn off the printer. With paper loaded, I'm going to hold line feed. I'm going to turn on the printer. And there we go. When you used an IEC serial printer like this Okidata, you have to be aware of a problem called bus clamping. Right now, I have the Okidata and a 1541 powered on and connected to the C64 Ultimate. However, I have the internal virtual drive activated as drive 8 and an image of the print shop disk. I can load the first program. Everything is fine. I'm going to turn off the printer. That first program loads fine again. Now I'm going to turn off the disk drive. Now I turned off both of these by cutting power through my power center. It's searching. There's no drive sounds. The entire system is frozen. No error message, nothing. Now I'm going to turn on the printer. It's loading. It says ready. There's our program. It unstuck. To understand why this happens, think of the Commodore IEC serial bus like a game of tug of war. The bus line's attention, clock, and data sit at 5 volts, which the computer reads as logical high or binary 1. Inside the connected devices, pull-up resistors constantly pull those lines up towards 5 volts. When that device wants to talk, it brings the line down to 0 volts to signal a logical low or binary 0. When you switch off a peripheral, like the Okidata 120, its internal 5-volt power rail drops to 0 volts. The unpowered logic chips inside the printer suddenly act like a heavy anchor, dragging the serial bus lines down towards ground. Things get more interesting when using a virtual disk drive on the C64 Ultimate. On original 80s hardware, every individual powered-on device on the chain, for example, the original Broderbund, your 1541 disk drive, had its own 1 kilo ohm pull-up resistor inside. If you turned off one external device, you had 2 or 3 powered on pull-up resistors fighting back. Together, they pulled hard enough against the dead device to hold the bus voltage at around 2.8 to 3 volts. Since TTL digital logic recognizes anything above 2 volts as a valid high signal, your system just kept running smoothly. Enter the C64 Ultimate. Because the Ultimate relies on FPGA chips to emulate 1541 disk drives and software, those virtual drives don't have physical circuit boards or physical resistors. There's only one physical pull-up resistor on the C64 Ultimate board itself, with only one resistor pulling up against a dead printer on the IEC line. The bus voltage drops just below 2 volts. The C64 interprets that low voltage as a device permanently holding the bus busy, locking up all disk operations. You have a few options to avoid bus clamping on the C64 Ultimate. The first, always keep your printer on. The second option is to unplug the IEC cable from the printer when it's off. The next option is the Hidden Machine Tweaks option. To find it, enter the configuration menu and press F2. Go down to Machine Tweaks and then Serial Bus Mode, and instead of all connected, we do C64 Ultimate Internal. Now I'm going to turn the printer off. The disk drive is off. Technically, it will not work like before, but this time it does. That machine tweak disabled bus clamping. The last way to fix it is to use what's known as an IEC kill switch. This is a simple device that cuts the physical connection to the printer or drive while it's off, so you don't have to repeatedly connect and disconnect its IEC cable whenever you want to use it. Well, I hope that you've enjoyed looking back at how we had to print back in the 80s, dealing with the speed, the sound, the software, and the unique challenges of bus clamping on that serial IEC line. Thanks for hanging out today, and as always, please find some time this week to reboot and remember the past.